7 Best Practices for API Design. It's an article written by Neil Kim on the website The System Design Newsletter. I've been building an API recently, and as I always do, I wondered if what I was doing was the best practice. So I'm interested in reading this. An API in any case is very, very useful. So that everyone comes across. So let's have a read. This post outlines best practices for API design. You will find references at the bottom of this page if you want to go deeper. Share this post and I will send you some rewards for the referrals. Once upon a time, there was a tiny startup. They had only a few customers, so they ran their website using simple monolith architecture. But one day, their site became extremely popular, so they set up microservices architecture for scalability. Yet they didn't know much about API design, and their public APIs often failed from spiky traffic. Also, they sent the entire dataset when users asked for just the latest data. Besides, it became difficult to manage APIs as they added more features. So they decided to study the best practices to design APIs onward. So is this a personal diary? Best practices for API design. Here's what they learned. Number 1, REST fundamentals. REST stands for Representational State Transfer. It's an architectural pattern for systems to talk with each other over the internet. It helps to organize data simply and clearly. Imagine a library worked like this. Get book door, return book door, read magazine door. Instead, libraries have one entrance with clear sections. Once you learn the pattern, it works everywhere. That's how REST APIs work. Resources, nouns, actions, verbs like get, post, put, delete. I don't get it. Imagine if a library worked like this. Get book door, return book door, read magazine door. This is a little bit confusing because why do we need the... I was a little bit confused because why do we need the first square? Can we just say libraries have one entrance with clear sections where you can learn the pattern and it works everywhere? That's how REST API works. I don't know why there's a first bit. I don't know if I'm missing something, but think of REST like a book library. Here it is. There's just one entrance to borrow or return books, while books get organized into different sections by subject. REST APIs organize data into resources similarly. So there's client and there's server. And you can make requests and the server returns with data. Here's how it works. Each data resources get represented by an API endpoint. For example, /items represents a collection of items, while item represents a specific item. The standard HTTP method allows interaction with the data. Get lets you read data from the resource. Post lets you add a new item to the resource. Put lets you replace an item with your data. Delete lets you remove an item from the resource. This approach makes the APIs predictable and easy to interact with. Yet, it might be limiting for some real-world actions, such as publishing a draft of a document. So it's necessary to have a balance between REST principles and a pragmatic approach. Let's keep going. Number 2, error handling. A status code tells the client whether a request succeeded or failed. API error handling means returning clear, consistent error messages if something goes wrong, thus making it easier for the client to handle the error properly. Imagine you are at an airport. A bad API error is like the departure board is displaying random errors when flight time changes. It doesn't tell you which flight, why, or what to do next. While a good API error is like displaying the flight name and reason behind time changes. Here's how it works. The response status code tells whether a client error or a server error occurred. and response body includes extra details about what went wrong. Proper error handling in APIs makes the site reliable. Yet, it needs extra effort and discipline to handle each failure scenario. Besides, error message must include only enough information to avoid security risks. Ready for the next technique? Number 3, API versioning. It's necessary to version an API so new changes don't break existing clients. Think of API versioning like publishing a new book edition. The old book copies that have already been sold don't get updated, but the new edition gets released with improvements, so readers who need the updates can get the latest edition, and those using the old one can read it without issues. So client, API server version 1, server version 2. Here's how it works. The API URL path includes the version number. The first version, api.com version 1 subpath, API version 2 subpath. The old versions don't get updated while new changes happen on the latest version, thus ensuring backward compatibility. Here are two alternative approaches to implement API versioning. HTTP headers. Client includes the version in the accept header. Accept. Application vnd.api.v1 plus JSON. It means API version 1 in JSON format. Query parameters. Client includes the version parameter in the URL. HTTPS app.com subpath version equals to 1. It means API version 1. But query parameters are designed for filtering or searching data, so it's better to avoid them for versioning. API versioning makes the site reliable, yet it increases the complexity and maintenance efforts, so use it only for breaking changes. Rate limiting. Rate limiting means controlling the number of requests a client can make to an API within a period. It prevents server overload and protects the API from abuse. Imagine rate limiting as telling a person how many things they can have during a giveaway. Client, rate limiter, and then rate limiter sends the request to API server. Here's how it works. The client sends requests to a server through the rate limiter. The rate limiter tracks the number of requests from each client using a counter. The rate limiter rejects the request in case it exceeds the limit. The API includes special HTTP headers in the response about the rate limiting rules. Very simple but elegant solution. Here are some of them. X rate limit, total requests allowed, X rate limit remaining, requests left before being rate limited, and reset, time when the rate limiting counter resets. While the API returns 429 too many requests, status code after the client exceeds the limit. Rate limits ensure the high availability of a site, but it's necessary to set a reasonable rate limit for a better user experience. Besides, many people might share the same IP address, so it's better to rate limit a person using an API key instead of their IP address for accuracy and fairness. Ready for the best part? Pagination. API pagination is the technique of breaking a large data set into smaller chunks. It lets the client request data in smaller parts instead of all at once, thus achieving low latency and reduced bandwidth usage. Imagine a big book with 1,000 pages. Pagination is like reading through it one page at a time instead of all at once. There are two ways to implement pagination. Offset pagination is the most common technique for interacting with a dataset in pages. Here's how it works. Number 1, the server queries the database to find the total number of items and pages. Number 2, the client specifies the page number and the number of items per page in the request. Number 3, the server responds along with pagination metadata. Offset pagination is simple to understand and easy to implement. Also, it lets the client access random pages. But it's slow with large data sets because the database scans the skipped records as well. Besides, there's a risk of inconsistent result if data gets added or removed during paging. Cursor pagination. If it uses a pointer to a specific record in the dataset, it means the server returns results after the cursor instead of skipping records. Here's how it works. 1. Unique sequential field such as ID or timestamp gets chosen at the cursor. Number 2. The client then includes the cursor parameter in the request. Number 3. The server fetches the next 20 items after the cursor using the database index. Number 4, the server includes the new cursor as well in the response for future requests. Cursor pagination doesn't scan skipped records. Instead, it uses the database index, thus making it efficient for large database datasets. Also, it gives consistent results even if data gets added or removed during paging, but it's complex to implement and doesn't support navigation to a specific page. So choose the pagination technique based on the data size and data update frequency. Ready for the best technique? Has this been written by ChatGPT? Because there's this pattern here. Ready for the best part? Before each ready for the next technique? I'm suspicious. I think it might be written by ChatGPT. Number 6. Idempotency. Idempotency means processing a request only once to avoid unwanted side effects. Imagine paying for something online and mistakenly getting charged twice for the same transaction. An idempotent API presents this problem. Client server. Okay, similar idea to limiter. Here's how it works. Now that I mentioned ChatGPT, seems kind of obvious. Number 1, the client generates a unique string UUID to use as an idempotency key. The client includes this key in the HTTP request header. The server processes the request and caches its response. Then it stores the idempotency key on an in-memory database. And the in-memory database gets queried to check if a future request has been processed already. Also, the client generates a new UUID whenever the request payload changes, thus ensuring only new requests get processed. Here are 2 alternative approaches to implement idempotency. Use database constraints such as unique keys to prevent duplicates. So use a message queue with built-in deduplication. Idempotency is essential for building reliable APIs, yet it increases the complexity and operational costs. Besides, the idempotency keys should be removed periodically to reduce memory usage. So use it mainly for critical APIs where retries could cause unwanted side effects. Number 7, filtering and sorting. API filtering means returning results that match specific conditions in request parameters. So client makes a request to server and server requests to database. Here's how it works. The client includes the filter parameters in the request URL. The server reads the parameters, then it queries the database with those conditions. The server returns only the matching conditions. Filtering improves performance by reducing bandwidth usage, but it increases the complexity of server logic. So use it only if specific data from a large database is needed. Okay. API sorting means ordering the results by a specific field using request parameters. Here's how it works. The client includes sorting parameters in the request URL. The server reads those parameters. It then creates a database query with order by clause. The server returns the results sorted by the request field. Sorting improves usability by ordering data, but it might slow down queries on large datasets without indexes. So use it only if ordering is important. The internet runs using APIs. While good APIs are consistent, predictable, and designed to scale without problems, so it's necessary to have clear documentation, useful error messages, and proper monitoring for APIs. Interesting article, but have to admit that I was more focused on seeing if this article was written by ChatGPT. And for some reason, the possibility of that, I don't like it very much. But I could be mistaken. Nine best practices for API security. I don't know. But either way, interesting article. Either way, I'm happy I read it. Thanks, guys. Like and subscribe.